Hello, everyone, and welcome to today's presentation. This is the North American IPAF uh, educational webinar series, and today's topic will be on reducing downtime in MEWP rental fleets, smart charging, tracking, and communication. Uh, as you saw on the beginning opening slides, we are going to entertain questions at the end of today's session. So if during the presentation you have a question that pops into your head, hit the Q&A button on your panel and enter that in, and we will address those questions at the end of today's session. We're very fortunate today to have with us a subject matter expert who is the Senior Product Manager at Delta Q Technologies, based in Vancouver, Canada. Uh, he has been in the industry for over 35 years. You can look at his resume in front of you, and we're very pleased to have Mourad Chergui as today's presenter, and he will provide us with a depth of information on this topic. So, Mourad, it's over to you.
Thank you, Tony, and welcome everyone. In this presentation, we will cover topics related to MEWP uptime. We'll start with looking at batteries, charging technologies, or specifically for MEWP. We look at some of the challenges faced with MEWP fleets and equipment. We will spend some time talking about what kills the battery and limit their lifetime. And then from there, we will talk about some best practices in battery and charging. Then we will talk about another topic related to challenges with MEWP, which relates to component failure. The last part would be about fleet management and telematics. And we'll finish up with a quick overview of Delta Q technologies. We'll end up with some key takeaways. And as Tony mentioned, at the end, there will be time to ask live questions. Electrification is very widespread in MEWP, mobile elevated work platforms. Indeed, a lot of equipment are electrified. And one of the segments that is most electrified is the scissor lift and, to a certain extent, compact crawler lifts. Most of the equipment today is battery powered, and these two segments make the bulk of MEWP fleets. But the combustion engines, traditional combustion engines, still exist, and they are still dominate in rough terrain booms. But there is a shift in the industry going to zero emission solutions and replacing combustion engine vehicles with battery electric ones. We will look at the heart of the electric machine, which is the battery. For MEWP applications, the most used chemistry and type of batteries are lead acid batteries. And they come in three major categories. There is the what's called the flooded lead acid batteries. So those like they distinguish itself, but the ability to be able to add water to the batteries. Their biggest advantage is they are lower cost compared to all the other chemistries. They are tolerant to overcharging, and they are very known in the industry, and they have been used for a long time. On the downside, these batteries are not sealed, and so they have to be used like on a flat surface, and they may spill acid into the equipment. Flooded batteries are very sensitive to high and low temperatures, as well as I mentioned, they try to dry out. So they need regular maintenance by checking on them and adding distilled water in the batteries regularly. Also, during usage and most importantly during charging, they need ventilation because they tend to exhaust some hydrogen, which is combustible if not well ventilated. They also, compared to the other chemistries, have relatively shorter life. On the other category, there are two types of batteries, which are absorbed glass mat, EGMs, and gel, and they are both known as valve-regulated batteries. Let's start with the both these technologies, the EGMs and gels. They offer relatively higher lifetime. They are maintenance-free. They are spill-proof, so they could be used sideways. And they also have lower self-discharge rate, which is an important consideration when storing equipment for extended period of time. AGMs in particular, they are better for cold weathers. They handle well very high discharge rate. They have excellent resistance to vibrations, which is like especially for rough terrain vehicles. They allow fast charging, meaning charging at a higher current compared to the other chemistries. They are the highest density in lead-acid batteries, and their price is mid-range. On the downside, they are extremely sensitive to overcharging, as well as sensitive to high temperatures, and they don't handle well very deep discharges. Gel batteries, on the other hand, are better for higher temperatures. The EGM are better for cold temperatures, but gel are better for high temperatures. They also work like they are fine with actually deep cycling them to lower state of charge, and they have the longest life if they are cared for and used properly. Their major downside is actually they are much higher cost than the other chemistries. They are very sensitive to overcharging and fast charging, so they don't accept that. And they, relatively to the other chemistries, they have lower power density. Lead-acid batteries are still the predominant type of batteries used for MEWP equipment because of the lower upfront cost, basically their prices, and the substantial weight they have because of the lead. So they act as counterweight in many of the MEWP applications, and they have proven reliability. Lithium-ion batteries, chemistries, is more and more used in the industry. And that's because they have much higher life, which is actually 3 to 4 times compared to lead-acid batteries. They require almost no maintenance, so they are maintenance-free. They have much higher power efficiency in terms of getting the power and the receiving it back. So overall, they offer the best, a much better total cost of ownership in the long run, in spite of being a higher cost. They also allow for fast charging and opportunity charging. Opportunity charging is that it's charging the battery mid work for a shorter period of time, as well as they are relatively lightweight and very compact in design, which is ideal for compact applications such as crawler booms. And their usage is more and more in the MEWP industry. We talked a little bit now, we covered a little bit what are different batteries used in MEWP. Let's talk about the chargers. So the chargers, they come in different options. So there are onboard chargers, which are built in the vehicle to convert the power from an AC outlet to DC power to charge the batteries. They enable to charge the vehicle anywhere where there is an AC outlet. And they are the most used type for MEWP applications. But for fleet owners that have MEWP as well as other equipment, you may find different other options for chargers. One of them is chargers that are portable and movable. So they are well suited actually for larger equipment, especially for rental places where the equipment goes from place to place. They are easy to relocate for fast charging across site, and then they are generally plug and play. Look, plug them to EC and you plug into the equipment, and here we go. The third category are stationary chargers. These are fixed industrial chargers for very large batteries. Usually they are installed in a dedicated, typically indoor space, but there are some options that offer this type of charger for outdoor space. For example, to install them in construction site or for outdoor environments. For fleet owners, and there are some specific challenges with MEWP equipment. The major one is premature battery degradation. Second one is operator misuse of equipment. Third one is unexpected component failure. And the last one is component replacement. So we'll dig further into a few of these aspects. Let's start actually with premature battery degradation. Let's examine what kills the batteries in applications in the field. There are four major causes that destroy batteries. The first one is improper charging. The second one is exposure to extreme temperatures. Third is discharge. And the fourth one is prolonged inactivity. And we'll get into more details for each one of those and look at ways on how we can avoid these issues. With improper charging, what it means is the battery actually, the lead acid batteries need to be properly charged. Both undercharging and overcharging significantly reduce battery life and performance. What we mean by undercharging is not allowing the battery a full cycle to charge. So basically, it's charged maybe 90% or 80% or 60% and return to service. This will the consequence of this is the battery will drain faster when using it, but additionally inside the battery there is sulfation that starts forming on the plates. This causes the capacity battery to even reduce further and a permanent loss of capacity. And as this progresses, it may lead to early failure. This phenomenon, undercharging, also causes terminal corrosions, which also may lead to battery failure. Overcharging, in the other hand, is leaving the battery on charge for a long time, beyond when it's full. So this excess charging cause excess heat, and higher temperatures start building up in the battery. It leads to plate corrosion, which reduces the capacity, as well as it leads to water loss, especially, which is a big problem, especially for valve-regulated batteries, sealed batteries. Flooded batteries, you can always add distilled water, but the VRLA valve-regulated batteries, you cannot add water. So if the water goes, it's permanently lost. So this over time, it causes risks and it leads to battery failure. How to prevent that? Basically, the best way is actually to properly charge the batteries. And in this regard, not all the chargers are the same. So a charger that have a specific profile for the battery will give the best performance for usage, as well as prolong the battery life. And chargers with features such as, for example, better voltage regulation and auto shut off when the battery is fully charged are best for prolonging the battery life. There is also from a battery fleet management, it's good to actually follow exactly the battery manufacturer guidelines. And once the battery is charged, is to allow enough time for the battery to rest before start using it, as well as a need to implement some procedures to actually regularly inspect the cable and the batteries and clean them up to make sure that everything is working properly, because corroded terminals or cables will cause lower voltages on the battery, which will lead to undercharging. The operator plays an important role on that because so that they can properly connect the battery, they can avoid as much as possible opportunity charging, which is actually charging for a small period of time and returning the equipment to use, as well as spotting warning signs on the batteries and reporting them, such as swelling, leaks, or heat generation. Delta Q Technologies does a lot of analysis and development of battery-specific charging profile, which we call in our industry charge algorithm. So these are purpose-built, designed specifically for one specific make, size, model of the batteries. The benefit is this is developed in collaboration with the battery manufacturer to meet the exact requirements and deliver optimal cycle life and charge performance. The trade-off with optimized charge profile is that it's made for that model of the batteries and cannot be used properly for other models. Right? On the other hand, there is another type of generic profile that they charge. Like you can have a generic profile that charges every battery, and that's claimed by many manufacturers. It's universal, so you plug an AGM or flooded or jet, different sizes, doesn't matter. The benefit is actually work with most batteries. However, it may deliver lower performance. Basically, the battery does not get fully charged, which means less runtime of the equipment, as well as shorter life. So this charge profile called algorithms is built to actually take into consideration optimized efficiency for the charging. It also look at the deep cycle effect and that's performance. It looks at the long-term cycling and aging behavior of the battery and taking that in consideration to adapt to this different changing environment, as well as incorporate various safety and failover mechanisms to protect the batteries. Our company, Delta Q, for example, have developed a library of more than 200 optimized charging algorithms for most prominent motive battery brands. And this is just a sample of a few brands that is there. But we have more than 200 different profiles, and we keep every time adding more. The second phenomenon that actually leads to shortening the battery life is exposure to extreme temperatures. Batteries are work best when they are used at 25 ambient, which is 77 Fahrenheit, and they don't work well in extreme heat and extreme cold. What are the effects? So the heat effect, it actually, if being used at very high temperatures, it accelerates the positive grid corrosion in the batteries, which lead to shortened life and early failure. As a rule of thumb in the industry, an average increase of 10 degrees Celsius above the nominal temperature 25 usually lead to halving the battery life. The battery life is cut by half, and then if you increase another 10 degrees above that, then the battery life is shortened to a quarter of what it's supposed to be. Cold is also not good for the batteries. One of the first thing is actually the battery capacity get decreased at lower temperature. The more you go down, the battery capacity basically what it can provide for runtime decreases. But this is in itself doesn't shorten it. It affect the performance, but not the lifetime. However, in certain cases, if the battery is using below freezing, and it causes plate damage and permanent failure after that. So how to protect the batteries? It is ideally using the battery, but especially charging between 0 degrees Celsius and 25, or between 32 and 77 Fahrenheit. It is also advised in extreme weather conditions to actually use chargers with temperature sensors, and so they can adjust the charging based on temperature. As well as a good practice is to allow a break, a cooling break after charging the battery before using it. And when storing the equipment, it is advised in colder temperature to maybe store it in a shelter, under a shelter, and in summer in a shaded area or well ventilated during a heat wave. The third effect is deep discharge, meaning using like fully using the batteries and bring it to almost zero state of charge, like decreasing. It is best to avoid, because actually lead acid batteries, they tend to get permanently damaged if they are being discharged below 20%. So absolutely, we should avoid as much as possible discharging below 30%, at the most 20%. When the battery is low in discharge, there are sulfations that start happening and loss of active material. Active material is the acid, so which reduce the capacity. Also, like with the sulfation, the plates get damaged, which reduce permanently the capacity and leads to early failure over time. And this is the more this effect even double if the battery is left non-charged for extended period of time. So how to prevent that? By first actually training operator on proper battery use. So, and instructing them not to drain the battery beyond 20%. So when that arrives, like to take back the equipment to charge and stop using it. Also use smart chargers with maintenance mode. And monitor on a fleet management, monitor that actually every equipment gets charged right after the shift. And in some cases, use a battery management system that will cut off the battery if the charge hits a certain level. So, like to properly care for the batteries is a responsibility that is shared between the operator and the fleet manager. The operator, for example, ensure that to charge equipment after every shift, finish the full cycle before using the equipment, inspecting and protecting the connections, avoid extreme temperatures, and reporting in fault. The fleet manager ensure that the batteries have the proper charges and the proper algorithms that go with it. Like the person review the charge data regularly, standardize routines, maintain the chargers, and act early on fault trends to implement preventive maintenance. The last phenomenon that actually shortens the life of the battery is prolonged inactivity. Like this is especially during seasonal storage of equipment. The lead acid batteries, they tend to self-discharge, basically lose charge naturally, and that amounts to about 3 to 5% per month at nominal temperatures. So after probably around 6 months, if the equipment not being used, the battery may lose 30%. And if it reaches that, the battery may start losing capacity, and the sulfation start building on the plates, which permanently damage the battery. This phenomenon is even more aggravated at higher temperature. Then it's not anymore 6 months. It may be after 2 months or 3 months that this phenomenon will happen. There is another phenomenon called stratification, which leads to the acid and water in the battery separating and exposing the plates to more corrosion. So how to prevent that is to store the equipment ideally between 0 to 25 degrees Celsius or 32 to 77 Fahrenheit. And as well as use high performance chargers with storage mode, like they have a special storage mode, and connect the equipment to the charger and connect to the grid throughout the storage period. If someone don't have this type of equipment, the alternative is to manually charge the batteries every few weeks. So four things that kills the batteries, and this is some like 10 points on how to help protecting the battery. The battery is the most valuable and most expensive asset for your MEWP equipment. It is expensive to replace, and if you replace often, like that's a lot of money lost. So there is some basic operation for the operators. Basically, complete the charge, complete the charge cycle completely. Charge immediately after shift. Keep the batteries and connectors clean and dry. Avoid extreme heat and cold during charging. Inspect the cables, connectors, and terminals regularly. A high-performance charger is not just about providing power to the chargers. It improves sustainability by extending the battery life and reducing battery disposal. It reduces the charging and idle electricity consumption, which has reduced the cost of operation, as well as comply with regulatory compliance, such as the California Energy Commission, and which is used in actually many other jurisdictions. And it allows also communication with telematics to battery management systems or other centralized systems to monitor and to get insight on the use and maybe abuse detection of the equipment. The longevity of the battery plays a pivotal role in not only ensuring the seamless functionality, operational efficiency, and higher return investment of MEWP equipment, but minimizing the need to replace batteries, which in some scenarios is very avoidable. So extending the span of the battery contributes significantly to sustainability by reducing the need for new production and minimizing waste. Longer lasting batteries decrease the environmental impact of mining material, manufacturing, disposal, while extending the time before recycling is necessary. So we covered aspects to do with the charging and batteries. Now let's look at the other equipment. What some of the aspects of component failure? Like the first one is about like the ruggedness of the components. Second one is about reliability and durability, and the third one is about implementing preventive and predictive maintenance. It is recommended that to ensure that the equipment being used uses actually components that are rugged and built for the purpose of MEWP, which work in a very harsh environment. There are liquids, there are acids, oils, all over the place around the electronic components. So the devices need to be well sealed to avoid water ingress as well as dirt. And that's not only applied to actually the equipment, it applies also to the fans, it applies to the harnesses, it applies to all accessories. Corrosion is another issue that happens there because of the presence of oils, of salts, fertilizers, solvents, battery acid in many of these around this machine, as well as UV light, which actually tends to damage some of the components if not designed properly. The second aspect is actually when looking at the equipment and the equipment OEM, ensuring they have implemented long life durability tests and tests in different real world conditions. This include thermal shock and temperature cycling, like be able to protect against extreme temperature exposure, as well as like outdoor operation. Shock and vibration. I mean, most of those MEWP equipment, they have solid tire with no suspension, so they are subject to a really high level of shocks, as well as the motors and the pumps that may be inside continuously working will create a high level of vibration on the equipment. Drop is another challenge. So the idea here is to ensure that the equipment used have been thoroughly tested by the OEM. The last aspect is about implementing preventive and predictive maintenance. To implement that, like it starts first of all with data logging. Smart charger, in fact, log battery charging parameters such as battery voltage, charge cycles, temperature, faults, alert, etc. So we'll talk about a little bit later about what some of the data that are present in smart chargers. So once logged, there is data collection. So by either telematics system, which is a centralized system that gets this data, or directly from the equipment by downloading the downloaded data. Then the data is transmitted either wirelessly by telematics system, or downloaded manually to and then moved to a computer for further analysis. Second, the fourth step is data analysis, and that's where artificial intelligence nowadays and the fleet management systems detect abnormal patterns and provide early warnings to the operators so that to avoid equipment failure. And then we can implement failure predictions and changing components before actually the machine is down. Looking at a fleet management telematics system, so it starts with having hardware for supporting telematics on the equipment integration. This allows for the fleet owner the ability to track the assets in different places, like in terms of location, in terms of usage, in terms of productivity. It allows for over-the-air firmware updates, so it's like actually maintaining the equipment. The equipment is also enabled to implement regular maintenance and scheduling and monitoring of the equipment, which provide a deep operational insight in the usage of the equipment, as well as with analytics and reporting. It's the basis for predictive maintenance. Such a system is the Ubiquicom ecosystem. Ubiquicom is a sister company to DeltaQ. It's part of the ZAPI group. They offer a wide selection of intelligent connected products and services. The offering range from telematics and remote diagnostic systems, safety and anti-collision systems, and the most advanced real-time tracking system to innovative tools that increases efficiency of fleets. So you have the telematic system, but how it can use the data is through IoT, Internet of Things, capable chargers. What does this mean? It's actually chargers that are CAN bus enabled. CAN bus allows communication with the machine as well as with the telematic system. So that allows, this communication allows to update the firmware, for example, on the charger if needed, as well as getting the user's data from the charger to the telematic system. So CAN bus is one way, but there is also some other ways to get actually this data, which is actually some chargers are equipped with USB interface to easily download the data into a flash drive stick, or through Bluetooth communication to download it to a smartphone. Once this data is collected, depending on the means, then there is software to actually go deep into analysis and looking at the fleet and operational management, and so that we can improve troubleshooting as well as reducing downtime for the machine. Smart chargers actually keep a lot of data inside them. what do they keep? They keep, for example, the charge cycle data, so like different parameters while for the last charge that is happened, like voltages, length, different points, which allows actually to spot unhealthy charging habits. It prevents early battery failures and reduce ultimately service calls and equipment down. The smart chargers may also keep like a log of all the charge cycles, like hundreds of charge cycles, basically months or maybe years of charge cycles that happens before, which are great to actually analyze, especially for fleet applications, like to identify issues at time. They also log faults, alerts, and temperature trends in the equipment, which will give insight into the usage. And this data is like smart charger will have means to actually communicate that via CAN bus to telematic systems. So all this data is gathered in a centralized location, allowing better fleet management. We'll finish up actually with a little bit about Delta Q technologies. Delta Q is a global leader on onboard, portable, and stationary chargers solutions. We have chargers that actually goes from as low as 350 watts all the way to 36 kilowatts and anything in between. We have an expanded range. The charging solutions offer a wide range of onboard and offboard charging solutions that enhance productivity and push boundaries in the electrification journey. The chargers have the characteristics of being intelligent subsystem that communicate with the battery and with the vehicle. They offer the possibility of real-time monitoring and adaptation based on current conditions. They integrate well with modular systems and system-level solutions such as telematics, and they are compatible with third-party charge batteries and through a large battery network. These charging solutions have been extensively used in MEWP, and as a matter of fact, Delta Q chargers are trusted by major OEMs, and this is just a few of the OEMs that provide that. And why Delta Q is a valuable company in the MEWP market is, first of all, because of the service it offers. First of all, the battery life, which is actually the core of the Delta Q, which provide being able to do exact profile, charging profile, fine-tuned for every model of the battery, and not only designing it, but also testing it and ensuring that it actually performs for extending the lifetime of the battery as well as the performance. The Delta Q also offers engineering and design support to customize solutions for the needs of specific OEMs, specific equipment, and to enhance performance and efficiency. And the last thing is we offer top-notch application design support, including training, servicing to ensure reliability of integration, and provide personalized integration options. At the end of this presentation, here is what I would like everyone to take with them. By leveraging advanced charging solutions in parallel with the right battery system, fleet owners not only improve operational efficiency today, they do so in alignment with a sustainable tomorrow. The quality of each charge directly impacts the battery performance and longevity. Reliable, high quality, and high performance chargers are essential for the electrification success. Training and operator awareness reduce the risks and improve the outcomes from using electric equipment. Telematics and asset management and unlock deeper visibility and reliability through preventive maintenance. I'd like to thank you very much for your attention, and we open the floor for questions.
Mourad, thank you very much for your presentation and the wide range of information that you provided everyone in attendance today. Again, as Mourad has suggested, we have the Q&A section open. So if anybody has any questions, please put those on the screen. We do have one from TJ Lyons. Is the weight of the battery type incorporated into the design tipping factors for MEWPs? Will additional weight be needed as lighter materials are used?
Absolutely, you're absolutely right. Yes. So the weight of the battery acts as a counterbalance. So and this is especially true for lead acid batteries because lead is very heavy material. Now, when the industry is moving towards using lithium ion batteries because of their benefits, yes, many OEMs actually they have to add additional weight there, like on the machine, like to act as the counterweight because the lithium batteries they may be half of the weight of equivalent lead acid batteries.
And I would try to add to that that in addition to that, while a manufacturer will design a battery system for a machine, when it goes out to an owner and an owner tries to maintain it and change it, the owner of the equipment must ensure that the battery that they are putting in the system is 100% equivalent to the batteries that they're taking out or replacing. So while the initial question was about it from a perspective of the design changing to a different battery type, in the field with owners, if they're going to make a change to that battery, they need to ensure that it is equivalent to the battery that is put into the system that they're replacing. If they do something different, that would be a modification. It could impact the stability of the machine if they're putting in a lighter weight battery system from what was in the original design of that machine. No questions, great info. You mentioned a cool down period after charging cycle. Do you have guidelines for models of specific batteries as how long this period is?
I would, yeah, good question. Every lead acid battery need a recent period, like one, because during charging there is heat generation while the battery is charging, and batteries are typically very warm. So it varies by manufacturer, but I would say an hour to 2 hours are typical in this industry after the end of the cycle. And high performance chargers, they will charge the battery. When it's finished, they will stop charging, and then they will like they may have signaling the signal that battery is still there to account for this cooling period.
So is there a guideline for that? I mean, is it like 20 minutes, an hour? Is it defined by the manufacturer?
It's defined yeah, it's defined by, but also it depends on the it depends also in the ambient temperatures. So the higher the higher you charge, but typically I would say a 1 to 2 hour is advised.
All right. So within the scope of that, we end up having individuals who do what we call opportunity charging, which is, all right, I'm taking a break. Let me go plug it in and charge it. What is your perspective or advice on the opportunity charging being harmful or beneficial or damaging?
It depends on the chemistry. So, for example, if using lithium ion like does that very well. There is like when opportunity charging lithium ion, there is no down effect whatsoever. So that's fine. Like they are designed for that. Lead acid batteries are very sensitive if they don't get full charge. But it depends on the chemistry. The least forgiving and actually it allows some opportunity charging are HEM batteries. So those they allow for opportunity charging. But the flooded batteries and the gel don't. They are not good with that. There is if a user keep doing that, there is a negative effect on the battery. So battery the way lead acid has to be discharged and then fully discharged, then discharged. If it's not fully discharged and you charge it a little bit, then return it. It's not good for the life of the battery because actually sulfation start forming around the plates, and which accelerate the degradation of the battery.
All right, we have another question, which is what can rental companies do to protect their assets when they rent the MEWP equipment out? Should recharging strategies be included in the contract and the agreements that they have with the renting customer?
Yes, that would be good. Well, the first of all is for the rental companies to actually make sure they have good chargers for the batteries, because that's an important part. And not only good chargers, but actually good charging algorithm for those specific batteries. That's the first step. Second one, yes, to include like wording or verbiages in the contract to make sure that the user actually use that. Often the user may leave the equipment at the end of the shift. The battery is completely fully drained, and leave it overnight or maybe for a couple of days over a weekend. And often the user may actually at the end of the rental period leave the equipment fully discharged, sit in for a few days, then it gets transported, comes back to the rental. Yeah. So yes, verbiage included there. But what the high performance chargers, smart chargers, what they offer is actually ways on how you can monitor that. So if you after every like after that charge, you go and then download the data, or have telematic system that pull that data, you download it, you view it in the computer, you can spot actually what happened in the last charge, if it was charged or not, and what happened before, which enable to enforce whatever in that contract and help protect the battery.
All right, we have one here which is asking for your opinion as our subject matter expert. In your opinion, is the lithium battery superior to the AGM and gel battery?
The short answer, well, the short answer in terms of performance, in terms of size, in terms of density, yes, and all of those. The only downside of the lithium batteries is the cost. Which is higher than the other chemistries. But like in terms of lifetime, in terms of being able to opportunity charging, even in like they don't have to be fully charged, so they are much better in terms of usage and longevity.
All right, and then a question is we see the primary decision in what charger is installed by the OEM as cost of purchase of the equipment. Is there a more ideal model of charger you manufacture that someone, for example, like Genie or JLG, should be using in their machines, but isn't due to cost? I'll put you on the line there.
Yeah. So I know like we deal with a lot of OEMs in this area. We supply a lot of OEMs, and like Genie and GLG are some of those customers. It's not only the quality of the charger, it's the quality of the charge. That's the right question. It's the quality of the charge that need to be adapted for those batteries. And with a lot of these OEMs, yeah, we design for them specific batteries because generally they have long-standing relationship with specific battery suppliers, and we provide them there. The risk is like with some vendors, or maybe for example when changing the batteries and the charger to install something else, where they don't have that care because some OEMs actually just look at the cost of the charger and to be like to reduce that, but not taking into consideration the quality of charge and the charging profile.
Okay, in understanding that perspective, and I'm going to hit that as a second part to this, which is, but originally your comment was, if you're a rental company, the quality of the charger is really critical. And now they're coming over and saying, well, we're not making that decision. The decision is being made by the manufacturer on the machine as we get it. So is it as a owner of the equipment, whether it's the rental company or someone who's buying it, is there something that they should be doing to analyze their charger on their system based on all the parameters that we talked about today?
Yes, they could, and as a matter of fact, they have been doing in North America, where especially for the larger the fleet you have, the larger of influencing the decisions of the OEMs that you have, and it has been happening in the industry. I won't go into specific details, but yes, it has been happening. Is for asking the manufacturer for a longer life. I know it's a little bit like the OEM is looking at lowering the cost, the bill of materials cost, but it's the life of the battery is the responsibility of the fleet owner. So there is ways, and the larger the fleet, that the fleet owner has more of a say. And we have customers where the OEMs will come to us and say, okay, customer X wanted to use these batteries and require this and that, and we design specific things for them. So that's happening in the industry.
So I know that we end up having users that are in Saudi Arabia when you're looking at the temperatures that are
Yep.
there, and you're talking about your 25-degree
Yep.
measurement. They're I'm going to say a good part of the year they exceed that, which means the life of their
Yep.
batteries is going to die. Then we end up having
Yep.
people who are in the great Northeast, like I am in New York, where
Yep.
today, we're at a lovely, you know, negative, 17 degrees when we wake up in the morning in Celsius.
Yep.
So, but that same fleet, that same battery is going to be used in 3 months where it's going to be a different temperature, and in
Very,
six
very hot.
months
Yeah.
where we're going to be. So how is it, that, when we're looking at this, that do smart chargers have the ability to go over there and assist this operator who is anybody and who doesn't really care about your machine outside of, I just want to get the job done? How does the smart charger influence that user of the equipment in doing the right things, making sure that we don't discharge
Yeah.
or overcharge?
Yeah. Before going to the charge, like there is a first consideration is actually what type of batteries do I use, right? So, for example, if like consistently the temperatures are high, I would suggest to use, for example, EGM batteries instead of gel or flooded. Like if it's consistently colder temperatures, then I would consider using, for example, gel. That's on the battery side. But on the charger side, smart batteries, in this like where there is extreme conditions, I would suggest that to use a battery with temperature sensing, with battery temperature sensing. So yes, for example, like if it's high temperature, like if it's I mean, like 90 degrees or 100 degrees or 110 degrees, that the rate of charge, or maybe even its stop charge when it's extremely high. So it regulates the charge based on temperature. So that's what as well as at lower temperatures. For example, if it's below freezing, for example, it stops the charge. So a charger with sensors to do temperature control charging is what will help with prolonging the life of the battery.
Okay, and then I have one last question for myself, which is in relationship to what are the most common operator habits that reduce battery life, and within that, I know you've touched on some of those, but I'll take a 100-foot electric lead, or other contributing factors that can do this. So from your perspective, what are some of those things, and then how is it that we can within training to this generic user out in the marketplace, the operator of this equipment, the guy who's going to be out there every day, charging it or not charging it every day, what information can we add to our training to really enhance this particular aspect of safe operation? So again, what are the common habits to reduce battery life, and what specific training can we add to remedy those issues?
The first one is plug the equipment to charge after each shift. So that's systematic. So that's one thing. but also the habit of ensuring that actually the charger start charging. So what happens sometimes is the operator goes finish plug it to the wall, but that that outlet, for example, is the breaker is stripped, so actually the equipment does not get charged. So not on. So this is practice, making sure actually it's plugged, and then that it ensure, for example, there is a light come on or something like that to ensure that actually charging is start is start. The second one is not to overdrain the battery. Many MEWP equipment does not have a cutoff, a battery management system that cut off the charge if it's below that. So basically, you can run the equipment to even below zero state of charge. So that's again training. So for example, if they see there is an indicator on the equipment that depth of discharge is like around 30%, they should stop using the machine because it's over there. So I think we do these two steps as well as proper connection of the battery, like basically like depending on the connector used, making sure that they are clean, that there is no corrosion, because the corrosion actually will cause undercharging of the batteries. So yeah, making sure it's plugged, making sure that actually the charging cycle starts, don't overdrain the battery, and do some basic maintenance before using the equipment.
Okay, well, that concludes our questions in today's session. Mourad, Chergui, thank you very much for your time, and for Delta Q for giving you the opportunity to be with us today and present and answer our questions. And thank you to all of our participants for joining us today on this session. We are now concluded and this webinar is over. Thank you all.